We're going to start by looking at some ionic dot and cross diagrams, but really we don't tend to do these a lot at A level, so it's unlikely that we're just going to get a straightforward ionic compound. It's often more complicated covalent molecules. Because of that though, people often forget how to do the ionic diagrams, and they are really quite straightforward and nothing new compared to what you did at GCSE. So we're going to have a look at calcium nitride, a more challenging example, simply because of the groups that the two elements are in. So calcium is in group 2, nitrogen is in group 5. It's nitride, not nitrate. So we just mean the negative form of the nitrogen atom. So that's a little tip, by the way, that "ide" always means that either the element is negative in terms of charge, or later when we look at redox, it means that it's the more negative in terms of electronegativity and dipoles. So I would just write down their electron configuration, and I don't need to use SPDF notification when we're doing that. We're just going to be doing just the normal standard shells, the full shells, because that is enough to explain the formation of ions. So calcium is in group 2, 2 in the outer shell, so when it forms the 2+ ion, it will become 288. So I'm going through that process just so I don't miss any shells when I do the diagram. Nitrogen is going to gain 3 electrons to become 2,8. When we're drawing the dot and cross diagram, it may not say that you have to include all shells, or it could be very specific. If it doesn't say, I would advise that you do show all the remaining shells in the ion. So there are 3 shells left in calcium, which is the biggest dot and cross diagram you would have to do. And so it'll have a configuration of 288. Don't forget to put the square brackets around the outside. This is the most common thing that people forget, and the charge of 2+. Nitrogen is going to have 2 in the first shell, 8 in the outer shell. I'm going to draw nitrogen as dots just to make it a little bit more clear where the electrons to make the 3- charge are coming from. Notice also that all my electrons are paired up in my diagram. You really should be doing that by now, especially for covalent compounds. Notice a little bit there about the fact that my 3 electrons that needed pairing up, I put them separately as well. So the reason I did that is actually to reflect something that does come from the SPD notification of how we do the ironing. So a nitrogen atom would have a configuration 1s2, 2s2, 2p3, which means that it would have 2 electrons which are paired in one orbit, in the 2s orbital, which I've shown at the top of that atom there, and the remaining 3 would actually be in singly occupied orbitals. So that is why we draw the dot and cross diagram like that. 3- charge on the outside. So the final thing that this diagram needs is some appreciation of the fact that, of course, to make the compound calcium nitride, you're going to need to not just have 1 of each ion. So the formula of the compound would be Ca3N2. And that's just in terms of balancing charges. Compounds do not have charges overall. So calcium, I need 3 lots of 2+ to balance out 2 lots of 3-. So what we want to avoid is, it's okay to use these numbers like this in subscript form in the formula, but we don't want to do that on our ions. We've drawn our ions separately, we're not showing them as part of a formula, so we actually put numbers in front as we would do if we were doing a balanced equation, for example. If you want, you could do 3 times, so you could put like a little X in front to show that you've got 3 lots of calcium ions. If you were only asked to do the outer shell, then just to be on the safe side, I would show 8 in the outer shell of calcium, although it could be argued that there were none, and you could in theory just draw the calcium in a square bracket with nothing around it. And then for nitrogen, Again, I would just show the 5 dots and then the 3 crosses, and notice that I've eliminated the circles. Eliminating the circles makes your diagrams a little bit neater. It also encourages you to have this idea of pairing the electrons up like little sides of a square instead of trying to fit them around a circle. That's also going to be really, really useful practice if you're not already doing this. So if you've not already eliminated your circles, it's really going to help when you start drawing larger covalent molecules and more complicated covalent molecules. It's going to make them look a lot clearer. And so that's something to think about when you look at the covalent videos, because that's really the hardest kind of ionic compound you're going to get. The only way they can make it any more difficult is just to show, to have different numbers like 3 and 2. But that's the maximum charge you can have, is a 3+ or a 2+ or a 3- or a 2-. So it's never going to be more difficult than multiplying by 2 or 3. So that's ionic compounds.